This is a video about graphing. My objective is I can graph trig functions. We're going to look at the 6 trig functions here, and we're going to talk about how they might change with amplitude and with period. We're not going to do on this video translations, either horizontal or vertical translations. So first of all, to kind of group things together, these 4 trig functions, sine, cosine, cosecant, and secant, they have a period that the standard period is 360 degrees, or in radians would be 2 pi. Whereas these two, tangent and cotangent, their period is 180 degrees, or pi in radians. So we're going to start by graphing the sine function here. On this sine function, you look at it, and what I'm going to do is just do one period of sine graph on the axis. Then I'll fill in the information about it. So looking at this formula, the number in front of the sine is the amplitude. So my amplitude is going to equal 2, and then the period for this graph is going to be 360. I'm going to work on this row in degrees. So 360 degrees divided by 3, which is 120 degrees. Now looking at my graph where those fill in, amplitude is from the middle of the graph to the top of the graph, so that's 2 units, and then it goes down 2 units to -2 for the going down for the minimum, and then my period goes out to 120 degrees. And so I'm going to do all the key points, and the key points that we're going to list here are where it crosses the axis or the midline, and where it goes to the maximum or the minimum points. So the first one where it crosses here is halfway to that 120, so it's going to be 60 degrees by doing half of the 120. Then where it's at the maximum here is halfway to that 60, which would be a 30 degrees. And then between these two, halfway between them, I could just be counting by these values of 30 degrees, 60, that would make this 90 degrees, or if you wanted to, you could average the 60 and the 120 to get that. Now let's look at the cosine graph here. Again, I'm going to just draw one period of cosine, and cosine starts up at the amplitude here, then it goes down, and then it ends up at the amplitude. So my amplitude for this graph is going to be 5, and notice that's where it starts, and it goes down to -5 down at the bottom for the minimum. Now let's talk about the period. The period is going to equal 360 degrees divided by a half. When I divide by a half, that's going to be the same as multiplying by the reciprocal, or by 2, so I get a period of 720. So out here to one period, I get 720 degrees. Halfway through to that minimum point, that's going to be 360. Halfway to that point where it crosses the axis, that's going to be 180 degrees. I'm going by 180s now. 360 where it crosses here is 360 plus 180, which is 540. And then finish it off at 720. Now let's do this tangent graph. We're going to do it in degrees, and remember the standard period for tangent is 180 degrees. Tangent, you do one negative asymptote and one positive asymptote, and then the graph will go through the origin, and then it slopes up and then goes next to that asymptote. Well, the period here, we don't worry about the amplitude, because if you think about it, amplitude is from the middle of the graph to the top. Since this goes off to infinity and down to -infinity, there is no amplitude. It doesn't have a value. So we're going to do the period. That's going to be 180 degrees is the standard period. Going to divide that by 9, so we get 20 degrees. For tangent, you got to take the period, split it into half. So you're going to go halfway to the negative side for the asymptote, so -10 degrees, and then the other half will go on the positive side for the asymptote at 10 degrees. And then it goes to the origin, goes through 0 there at the middle. All right, now those we did in degrees. Let's do 3 graphs in radians. We'll start with the cosecant graph. And to do both cosecant and secant, I'm going to look at what the reciprocal is, and that will guide the graph of cosecant and secant. So the graph, the reciprocal of cosecant is sine. So I'm going to graph one period. I'm going to do a dotted graph here. One period of sine. And then what I've got to recognize, that sine goes up to 1 and down to -1. It goes all the way out to 360 because the period is, I'm going to do it in radians here. So let's do this as 2 pi. Okay, and that's because we haven't changed anything. There's no number in front of the x in order to divide by. Halfway to 2 pi is pi. Halfway to that is pi over 2. We're going by half of a pi, 1 pi, 3/2 of a pi, and then 2 pi for the graph. Now, when I draw the cosecant graph related to this, what I do is think about the reciprocal. The reciprocal of 0 is undefined, so wherever it crosses the axis, I'm going to have instead an asymptote. And then wherever I have a 1, a maximum of 1, the reciprocal of 1 is just 1. Now here where it's 1/2, the reciprocal of that is 2. Where it's 1/3, the reciprocal of that is 3. And so what you see is that the graph will go up toward the asymptote. And then down here, the same thing happens because the reciprocal of -1 is also -1. And then the reciprocal of -1/2 is -2, etc. And that will give me values that look like this on the graph. So I get these U-shaped graphs that's a reciprocal or the flip of what the sine graph does there. All right, now let's do the same sort of thing with this one. Now, this one has a different amplitude, so the amplitude here of 4 is important. Also has a different period, so I'm going to say what the period is. The period's going to be 2 pi over 2, which gives me just pi for a period. Now I'm going to draw the reciprocal graph, so the cosine graph. Cosine graph will look like this. And it goes up to a 4 and down to a -4. And then out here, it's going to end at pi. Halfway to that is pi over 2. Halfway to pi over 2 is pi over 4. And then halfway to between those two, I'm going by 1/4 of a pi, so I need 3/4 of a pi here. So that halving process, if you have to, you just average 1/2 and 1 pi. Now, that's what the graph of cosine looks like. To draw a secant, we use that same pattern, that wherever it crosses the axis is an asymptote. So I'm going to draw an asymptote here and here. And now you might say, hey, the reciprocal of 4 is not 4, but really what we're doing is we're doing the reciprocal of secant. We get secant, the value will, cosine would be a 1. The reciprocal then would be 1, and then we multiply it by 4. So every minimum and maximum still is a common point there. So you look at this minimum point and draw it down there. And then here, the maximum point, and draw it up here. So I've got a half there, it gives me a full period for that one. All right, now let's do the cotangent graph. Looking at the cotangent, its period is pi. And cotangent starts with the axis being an asymptote, and then it goes out a full period for an asymptote. So let's see what the period is here. Now the period here would be pi over 1/3. Let's go ahead and multiply pi times the reciprocal, 3 over 1, and then we get 3 pi as our period. Now, Since we start at 0 for this one, we go all the way out to 3 pi for this one, for a period. Now, cotangent, it goes in the opposite direction. This 2 in front, since there's no amplitude, we don't necessarily represent it on the graph, except you have to know that that's actually doubling the value. So whereas cotangent might come in gradually and go out, it's going to come in a little bit faster. It's still going to get close to this asymptote, but it's going to come in a little bit faster. Kind of hard to represent or decide if that is faster, but you do have to know that that 2 makes it double in how fast it goes up. So our graphs are dependent on the shape, which you have to look at the standard shape for all 6 of these graphs. And you have to look at the period. That will tell you how far it's stretched out. That will be influenced by the number that's right in front of the x. And then the amplitude for sine and cosine will, that number in front will tell you that these stretch up faster if there's a number in front that's a larger number. Or here, it will influence the reciprocal graph, and then we'll graph this one to just go from the minimums and maximums. So look for the standard look of each of them, standard shape of it, as well as the standard period of it, and maybe the amplitude, and then draw your graphs from there.